Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to talk about a stable circuit using LM555. According to the datasheet of LM555, this is a circuit. You had to connect the pins just like this. You had to connect the important nodes are the pin number 2, which is a trig, and number 6, which is a threshold. You had to connect these two together to produce Astable, and in this Astable operation, this capacitor charges through RA and RB, and this charges through RB, and these two, the pin number 2, it somehow compared its voltage with 1 divided by 3 VCC, and for this node it compares with 2 divided by 3 times VCC. So these two are critical voltages to produce a pulse waveform in the output as an Astable circuit, and you can see some formulas in here. Almost 0.7 times RA plus RB times C, it is a T1 for charging time, and for discharge 0.7, almost 0.7 times RB times C is for the discharge time, and the summation of these times provide T, and the frequency can calculate it as 1 divided by T. So this is how you can produce it, and we're gonna verify these values in this simple circuit. This is 2 and 6 pins connected together. This is RA, RB, and this is a capacitor. Let me just write T1 equals to almost 0.7 R1 plus R2 in here times C1, and the other T2 is 0.7 times R2 C1, and the total T equals to T1 plus T2. I'm gonna comment this to have it as our total time, and so the frequency would be 1 divided by T, of course. So, and this is the output pin, V out, and before we're gonna see the output waveform, let me just give this sense what is these values. For T1, 0.7 times R1 plus R2, this is going to be 6.9 times C1, which is 10. Okay, so this is the value, and what is the unit? Kilo times nano, which means this is going to be in microseconds. So almost 48 microseconds for the charging time of the capacitor. And how about the T2, which is the discharging time? 0.7 times 3 times 10, which is 21 microseconds. Okay, these are the times that we're going to verify this in this simulation. So here it is. This is our output voltage and VCAP voltage. Why VCAP in red? Because the VCAP shows us when to change the output. If the VCAP, this voltage, you see here, this is because our VCC is 12 volt, 1 divided by 3 VCC is 4 volt, and 2 times VCC divided by 3 is 8 volt. So the waveform of VCAP is between 4 volt and 8 volt, and this is our changing happens here. The output goes to high when it's above VCC divided by 3, and when it reaches to 2 divided by 3 times VCC, it goes to low in the output. Okay, this is where changing happens, and about the time that we just calculated, the two values, 48 microseconds and 21 microseconds. Here, look at this one here. Okay, here this is for example this one 240 microseconds, and here is 288, which is a total of 48 microseconds for during on time or charging time of the capacitor or for the output, and for discharging from 288 till 309. Let me just calculate this. 309 minus 288, it's had to be almost 21. Yes, 21 microseconds for the off time. So the values are verified, and you can change its values according to whatever the pulse in the output you require for your entire circuit. And this is how you can provide Astable circuit using LM555. Of course, there are other ways as well. For example, using bipolar transistors and resistor and capacitors, that you can produce Astable or pulse in the output. And there are some differences. For example, this kind of circuit, because you're using IC like LM555, so it's somehow so sensitive to the noise. And if noise is a problem for you guys, it's better to use bipolar transistors. Okay, and I try to create another simulation in LTSpice, so you can get the sense what happens there and how you can provide a circuit to create Astable in the output using just transistors and R and C's. Okay guys, this is the end of this video. If you have any questions, let me know in the comment section. I will see you in the next video.